Let's go ahead and begin by making sure that you can say the word. So I like for you to say this word with me, probability. Good. For probability, looking it up, it said a likelihood or a chance of something. Now the next word, statistic. Good. Probability and statistic. Let's say it together. Probability and statistic. All right, good job. Statisticians. I know this one is a little bit more difficult. Statisticians. Looking it up, I have the definition: an expert or person who use data to make decisions. These are people who study the field of mathematics, or who accumulate data, who work with a lot of numbers, and you will be surprised when I Google search statistician. In 2021, statisticians continue to be a best job. And this is a post that I find on Google here. It said from monitoring the pandemic impacts to election projections to social justice causes, the biggest issue of all of these all have one thing in common: statisticians and the data scientists play an important role. Statisticians have very high career rankings, salaries, and everything's related. And it's that USA Today named statistician at the number 5 top job in America for its very good work environment, very low stress at work, and very good projected employment growth, making it one of very few careers to receive the highest mark available for all 3 categories. So numbers might be stressful for some of us, but you can see this is actually an ideal job to go into and to study and to. On the guided practice problem that you see on this page right here, we are going to go over the probabilities part. Recall in the previous lesson, we show you how to do the statistic part, including the mean, median, mode, and range. We went over this previously. Now, today we're showing you the second part of the probabilities and statistic units. So all of these problems are probabilities problems, and we might have different way of asking the same questions. One direct way is, what is the probabilities of? What is the chance of? What is the odd? What is the percent? In the first one, we have the problem with the marbles in the bag. Remember I mentioned before, they love to bring this marble things up for probabilities for some reasons. Okay, let's start. There are 23 marbles, each a different color in a bag. One of them is pink. What is the probability of reaching into the bag without looking and selecting a pink marble? Choose an answer, and you have 1 out of 22, 1 out of 23, 23 out of 1. Pause the video and see if you can answer this question for yourself before you see the answers. Before we begin solving, I want to point out the notation for writing probabilities. Here you will see with my laser points, I underlined it for you. P on the outside stand for probability, and the inside of the parenthesis we say, what is my chance of getting that pink marble? That is the notation of how we usually write it as a question before we answer it. Probability of picking the pink marble is equal to, and you see there's a total of 23 in a bag, right? Imagine reaching in. What is my chance of getting that? 1 out of 23, that's the only correct answer we have there. Next problem, there are 15 girls and 13 boys in 6 periods. So this is a more realistic problem here. If Coach Mullins randomly select a member of 6 period, what is the probability that she will get a boy? Let's go ahead and write it with the probability notations. To answer this question, remember we have 15 girls, 13 boys, and we're asking what is the percent, what is the chance, what is the probability that the teacher will get a boy when she randomly select one, right? Or maybe close her eyes and select one student. What I would do first is I would add the numbers of boys and girls so that we have the total, and then we will work from there. So here's the girls numbers and here's the boys, and if I add those two, we will get 28 student total. And how we write it, the P doesn't stand for peak, okay? It's probabilities of, inside the parenthesis we have the person, boy. So how many boys? 13, right? So my chance of getting the boys would be 13 out of 28. So you want to go ahead and put 13 on the very top of 28. I have a fraction now, and the first thing you want to double check anytime you have a fraction is it in the simplest form? If it's not, I need to simplify. When I reduce it, I have to divide both the top and bottom by the same number. So 13 cannot divide by 2. Even though 28 can divide by 2, I'm going to stop there because that is the simplest fraction we have, 13 out of 28. But keep in mind that we could have other answer form, like fraction we already have, like decimal, like percent. Divide by 28. And I'm going to get a decimal. So my answer is 0.46428. We move the decimal 2 places to the right to get percent answers. On the next problem, we have a little spinner. Probability notations, we have probability of not getting an A. How many letter A are there on this circle? We have 2 letter A, right? But we want the probabilities of not getting an A. Remember to simplify. That's the always we want to do that when we have fractions. So here we are going to count and see how many letters there are total. So first I get 1A, 2A, so those are the only A, 3, 4, 5, 6, 7, 8. There are 8 letters total in that circle. So the probability of not getting an A is, I take 8 minus 2 and I get 6. 6 out of the total 8 letters. The thing you want to do first is reduce 6 over 8. I can check to see if I can reduce by 2, by 3, by 5, 6 and 8. They're both even number. I know I can reduce it by 2. 3 over 4.
Changing 3 over 4 to decimal, we get 0.75 decimal number and get the percent to be 75%.
True or false, the probability of an event occurring, probability of A, can be expressed as a fraction, a decimal, or a percent. All of it. So the answer is true. That's complete our work today, and I would like for you to go ahead and try the last practice page. And go ahead and pause the video or stop the video and try it on your own first. Let's go ahead and finish the last page with all guided practice problems here. The chart below represents the number of marbles in a jar.
Probability of green is equal to, and we are asking you which of these would be the correct answers. Right here we have 3 choices for possible answers. Now the chart is red, we have 5, yellow, we have 11, blue 7, green 10, brown 5.
So the first thing I want to know is how many are there total, because this is all in the chart. So we are adding all of them. Red, 5, yellow, that makes 16. Well, there is a better way that I can add, right? 5 plus 5 is 10, and that's the trick. The one that make 10s, add them first, and then that would be easier. Then I have 10 on green, so that's 20, and then with the 11, that 31, and then plus 7, I get 38. Now you have to be careful when you mix up, because you might get confused yourself, or you might forget to add a number. So do be careful if you're going out of order. Okay, so I have 38 total, and I don't see the 38 on the denominators on the answer choices here. Should I get worried? Look, it's out of 14. This is one is out of 19. This one is out of 28. Where's the 38? Maybe we need to write it out so we can get a better idea. Probability of getting a green, remember we don't want any marble, just the color green. The color green, we have a total of 10. So this is how you're going to solve this problem. You put it 10 out of 38. And I think you guys can see where we're going with this number right here. 10 out of 38, we can reduce it. 0 and 8 are even number. I can be 5 by 2, by 4, maybe more. But let's start with 2. And 38, if I divide by 2, I would get 19. So 5 out of 19 is one of these answers right here. My answer is 5 out of 19. Next one. If you choose from the following M&M colors, what is the probability that you choose blue? Ooh, there's so many in the picture. Okay, the good thing is we list all of the M&M for you.
5 green, 6 yellow, 8 blue, 7 brown. Pause and try if you can see if you can get the correct answers.
And write this in probability notation. We are asking about blue, so we will put blue inside the parentheses. Okay, so how many are there?
We have 8 blue. That number is on the top. What number go on the bottom? Yes, add all of them so we can find the bottom one. So 7 plus 8 or plus 6 plus 5. So order doesn't matter here. And it doesn't look like there are any number that can make a 10 for me to do a quick addition here. So I'm just going to go in order. 5 plus 6, 11. Plus 8 is 10, and then 19 plus 7 is 26. Possible answer right down here as 8 out of 26, but don't go with the first answers. It may not be the correct answer, right? We gotta reduce whenever possible. Don't forget that. And so we divide both A26 by 2 because A and 6 are even numbers. So I start off with 2. If it's an odd number, I would start with 3, 5, 7. Or let's go ahead and divide by 2. I get 4 out of 13 is my simplest fraction I have here. And the correct answer is 4 out of 13. Let's take a look at the colorful spin wheel over here. You spin the spinner 3 times. Find the probability of these 3 events. Probability of getting red, an odd number, or a number 3. Pause the video and try to see if you could get the correct answers on your own. Okay, let's check our answers. Probability of getting a red is 1 out of 6. Probability of getting an odd number, I get 3 out of 6 because 1, 3, 5 are odd numbers, so 3 out of 6. And wait, if I write 3 out of 6, I can write 1/2. The last one, probability of getting a 3. A 3 is just one number out of the 6, so it's going to be 1/6 again. So let's go ahead and try to multiply out. When we're multiplying a fraction, you will remember we just multiply the number across. So numerator times numerator, denominator times the denominator. So 1 times 1, and they're all 1 across on the top. So that's going to be 1 on the top. And then on the bottom, I have 6 times 2 times 6. So 6 times 2 is 12. 12 times 6, 72. You can also take 6 times 6 first, which is 36 times 2. And that would give me 72. 1 out of 72 is our answer for this problem. You may also use a calculator. 1 divided by 6. I will get the decimal of 0.16, and remember there are 2 of them. So I'm going to go ahead and multiply by 0.1666 again. And then multiply by 1/2 would be 0.5, right? So 0.5. And there we go, 0.01. The percent, if we are writing this in percent, is very low. It's going to be 1.3%. Now I'm taking you to the website called Math is Fun, and I want to show you this part right here, ways of showing probability. I think this is a very good, remember 0 to 1 or 0 to 100% only. Impossible is 0. And then the very certain that you're going to get it is 1 or 100%. And then in between, we have even chance 0.5 is in the middle, so 0.2, 0.3, that's unlikely. When it's getting to the certain and the getting closer to the 1, like 0.7, 0.8, 0.9, then it's going to be likely. It can be expressed as decimal, fraction, or percent, and we're going to go ahead and show you the formula that we have for answering that last questions there with the spinner. So for the independent event, in the next 2 minutes, I'm going to show you the difference between independent versus dependent events. This is done by this person. You can watch the whole video on YouTube by Hornfeck. A video I'm showing you is called Independent versus Dependent Events.
So we've got this bag of marbles on the left. Using the bag of marbles, what is the probability of pulling a white marble 2 times in a row? Another way to write this would be probability of white then white. So we're going to give 2 different scenarios. The first scenario is going to be when you pull a marble and then put it back for the second trial or second event. This is known as independent events, when you start with the same amount of marbles for both events. So I see 4 out of 10 marbles being white. So that's the first event. And then you take the second event. You've put the marble back in, and so you still have 4 out of 10 marbles. You're going to get those fractions in lower terms, and then you're going to multiply, and you have a 4 out of 25 probability of pulling a white marble 2 times in a row. So then the second situation is when you keep the first marble from the first event. That's known as dependent events. So looking at the bag of marbles, there's still 4 out of 10 marbles for the first trial, for the first event. Now, suppose you pick a white marble. I'm putting an X over one of them. Now we're going to have 3 white marbles left out of how many marbles altogether? There's 9 marbles altogether. So it's a 3 in 9 chance now that you'll pick a white marble. So you get those in lowest terms, and you have 2/5 times 1/3, and you have a 2 out of 15 chance of getting a white then white when you keep the first marble. So that's dependent events. The second event depends on the first one. Whereas in independent events, they don't affect each other. The 2 events do not affect each other.
That is a very good example to clarify independent and versus dependent for you. So that's our formulas of the independent event, just like the spin wheel problem that we did earlier. I hope you have a better chance of solving these problems. I hope you enjoy the unit on probability and statistics. You can see why Las Vegas or maybe some of the casino will have a list of all the statisticians, and if once they enter or maybe not upon an entry, but when they start to win a lot, then they will probably go by that list and say, hey, are you on this blacklist here? And that's when they go and get to a private room where they will have a talk, because these are the people that will beat the odds. They will be able to calculate and say, hey, what's my chance of winning here? It's time now to go ahead and practice problem, post it in your Canvas class or your digital math notebook.